Hey guys, Mr. Weber here, and today we are starting our unit over geometric transformations. And now, what that means, well, the word geometry just means shapes, and the word transform means to change. So, we're going to be looking at how we can change shapes, more specifically, changing shapes' position, where they're located, or their size. And we're really going to be looking at four specific types of transformations in this unit. There's translations, which is just moving your shape to a new location. Reflections, which is just creating a mirror image of your shape. So, rotation, which is just turning your shape around the origin. And dilation, which is when your shape is made larger or smaller. All right, so let's take a bit of a closer look at each of these transformations and see what they actually look like on a grid and maybe start to notice some of the differences between them. So the first one we have is called translation. And you might notice that word kind of sounds a little bit like the word transportation. And it's a great way to remember what this actually does, because transportation is a way to move people and objects from one location to a new location. And that's really the exact same thing that translation does. It takes your shape and it moves it in any direction to where it is now in a new location. And it looks like this. This is a great example of a translation where we are taking this shape, this triangle ABC, it is getting translated over to the right, just moved over to the right. A word that will help you remember what translation does could be slide, because all you're ever going to do is take your shape and you are sliding it in a certain direction. This example specifically, what is happening here is that triangle ABC is being translated 7 units to the right. And so you can also think about this as it is taking each of these x and y values here, and the way that they are being changed, since it is only moving to the right, only moving further up the x-axis, the x values are all being increased by 7. It is moving 7 units to the right, so we are taking our x values and adding 7 to them. But since it isn't moving up or down in this specific instance, the y values are staying the same. Let's look at our next example of a transformation, which is reflection. Now, this is a word that you have probably heard before when you think of looking in a mirror. And really, this is a perfect example of exactly what reflection does. When a reflection creates a mirror image of the shape. So it would look like this. We could take that same triangle, ABC, and what it's going to do is it is going to create an exact mirror image on the other side, in this instance, of the y-axis. So the y-axis is acting like a mirror right here. The word you can think of that goes with reflection would be to flip. If you notice, everything from this triangle is flipped when it creates the new triangle on this side of the axis. So in this example, it told us to reflect triangle ABC over the y-axis to create our new image. And what happened, this example, was it changed all of our x and y values to, since it switched it over the y-axis, our x values turned into negative x values, and our y values stayed the same. So oftentimes with reflections, what they can do is they can change the signs. They will change the signs of one of your x or y values. The next one we've got is rotation. And this transformation is another word that you've probably heard of before. Rotating, you could think of it like how the hands on a clock rotate around the clock. And what rotations do is they're just going to turn your shape around the origin. So it could look something like this. This is a great example of a rotation. And in this example, we have the shape being rotated counterclockwise. Now we know that because a clock goes clockwise. It goes in this way, 1, 2, 3, 4, 5, all the way through 12. So since this shape is going the opposite direction, that is called counterclockwise. The word that you can think of that goes with rotation would be to turn. It's simply turning your shape around. And so this example specifically asked us to rotate triangle ABC 90 degrees counterclockwise. And you will see more about what the different degrees of turns are going to look like and how they're going to change your shape. For this specific instance, when we rotated it 90 degrees counterclockwise, it changed our x and y values by switching them to where now they are negative y values and then your x. So it switched the order of our x and y values, and it even changed the sign on one of them, which is something that could happen with rotations. The last transformation we have is called dilations. Another word that you might have heard before, if you've ever heard about maybe your pupils dilating, that is when the smaller black part of your eye can grow larger. And this is, once again, a great example of what the actual transformation does. It just makes the shape larger or smaller. So here's what it could look like in an example. Right here, we have this shape A, and it is growing larger because of a dilation. A word you can think of that goes with dilation would be zoom. You're either going to be zooming in on the object or zooming out is one way you could be thinking about it, but it is really making the object larger or smaller. And in this specific example, it was asked to dilate quadrilateral A by a scale factor of 3. That means that this shape becomes 3 times larger to create the new image. And what's happening to the x and y values? Well, the original x and y values are now being tripled, multiplied by 3. 3 times the x value and 3 times the y value. In each of these transformations, the actual shape that you start with is the same shape that you end up with, even though it's gone through some changes in maybe its position, its size, or the direction that it is facing. So try to answer these questions right now. In which of these transformations does the shape actually change in size? And in which of these transformations does the shape actually change in the direction that it is facing? In each of those transformations, you might have noticed that there were 2 shapes that were created. The original shape that you start with, and then the new shape that is created after doing the transformation. That original shape that you start with is what we call the pre-image. And then the new shape that is created after the transformation happens is called your image. And these are named after the points on the shapes. So this pre-image here, this triangle could be called triangle ABC because it has the points A, B, and C. And then when you create your new image, each of those points now has an apostrophe after it. And this could be called triangle A prime, B prime, C prime because you read that apostrophe as the word prime.